Great. Okay, cool. Thanks so much, everyone, for being here. I'm going to go ahead and get started here in a moment. But first, I always like to set up and make sure things look good on my desktop. So let's go ahead and check that out real quick. Okay, great. Recursion for days. So let's go ahead and get to it. And you'll notice that in the description of this class, oops, okay. If it's not on there, let's see, 15 more lines. All right, great. You'll notice that it says code available at github.com, Lorraine and Nicole Python-crash course. So in there is a Python notebook. There's the Python notebook as slides, and there's a little code snippet that we can go ahead and review towards the end. And you'll notice that there's some stuff that's missing from that, as I don't like to publish credentials for APIs on the internet. It's not usually the best thing to do. So let's go ahead and get to it. Okay, great. So as I was saying, I am going to be using today a combination of an IPython notebook and the PyCharm interactive developer environment. So provided things look good, which I do this and then I do this. Okay, great, that looks good. That looks awesome. Okay, cool. So let's hide this. All right, cool. I think we're pretty much all set. So let's chat about Python. So first of all, I just want to thank so much SheNomads, specifically Latoya, for inviting PyLadies Chicago to participate in doing this class today. SheNomads, if you don't know, has a brilliant podcast that talks about various topics such as salary negotiation, and it also is a community for women who work remote, hence the fun play of being a nomad but a she-nomad. In PyLadies Chicago, I will chat about a little bit. So let's go ahead and get started. First things first, let's chat about what today we're going to cover. So today's learning objectives. We're going to briefly chat about the history of Python, examples of Python in use, some basic Python data structures, some syntax and control flow. We'll look at what Python modules are, and then we're going to go ahead and look at some code that's going to pull down data from the Twitter API. At the end, I'll give a few recommendations for resources to help you continue your journey to learn Python. So what will today not be? This is by no means a deep dive. This is kind of things that I think that are important to observe, some good code, just to get some good code snippets, just to kind of get yourself acclimated to what Python code looks like and to help you continue with learning. There is there's links provided so that you can go ahead and click through into the documentation should you need. And I always encourage folks, read documentation. If you are coming from languages like JavaScript or Ruby, Python is very comfortable and very close to those languages. The one thing I'll say for folks who might have a strong Ruby background, the Python docs are a little bit denser. So we'll actually look at them a little bit together and see how we can kind of navigate that. So quick notes on who I am. So I'm Lorraine Mesa, and I run PyLadies Chicago along with Jess on Rhyme. So there's two of us who are the organizers, and PyLadies Chicago has been around for about, I think, a year and a half. Yes, a year and a half. Basically what PyLadies is, it is a community for women who do Python. So while we do say that we are first and foremost about creating a space for anyone who identifies as a woman and loves to do Python, of course we're open and friendly to folks who may identify another way. We just always ask folks to adhere by our code of conduct and to be mindful of others when participating in our events. We also do things like online classes. So yay, excited about that. Other things that I like to do, well, I am on the board of directors for the Python Software Foundation, which basically means I get to do really fun things like work on making sure that we have active diversity initiatives. The Python Software Foundation, one of the most exciting things I think that we get to do is help people fund their Python workshops, their conferences. So if you have a really cool event that you want to try out, go over to python.org, check out the grants section, and it will outline how you can actually require for getting funding for your events, what kind of information is necessary. And that's really a super fun initiative of the Python Software Foundation. Some other things I like to do, I have run Django Girls once now in Chicago, hoping to bring it back. And I work as a platform engineer at Sprout Social, a business-to-business social media management analytics tool. Pretty awesome. If you are in that space, I encourage you to check us out. So let's chat a little bit about Python. So first things first, that is the original Python logo. I got such a kick out of it. It makes me think a little bit of a, I don't know, a video game from the 80s, and affectionately, Python was first created in 1989 in the Netherlands. So this awesome guy here with the Python, with an actual Python, is Guido van Rossum. So Guido is what we like to affectionately refer to as the benevolent dictator for life. He's the main creator of Python, as in he is the creator. The name for Python does in fact come from Monty Python's Flying Circus. And I think that this description of what Python is, and really what is the philosophy behind the language, I think Guido's words here capture a lot of that. So he says Python is an experiment in how much freedom programmers need. Too much freedom and nobody can read another's code. Too little and expressiveness is endangered. So that right there, I think, talking about what Python is quite a few things. Before we get into talking more specifically about what Python is and what it is not, I do want to emphasize that we are actually going to be chatting about Python 3. So why Python 3? If you are a person on a Mac, so for example, I could just do something like this, and you'll notice that it comes with Python 2.7 installed. That's great. Why would I want to use another version of Python? Well, that's because Python 2.7 will only be supported until 2020, and the only kind of updates you can anticipate to see in Python 2.7 are things like minor security fixes or support for new OS versions or tool chains. If you want an update for when the end of Python 2.7 will happen, you can check out this nifty little Python clock. And it looks like 3 years, 7 months, 22 days, and you get the gist of it. So it's kind of Guido at his PyCon 2016 keynote said that there will be a quote official end of Python 2.7 party at PyCon 2020. If you are a big Pythonista and you want to come join that, I'm sure it will be very amusing. So beyond just the fact that Python 2.7 is going to be retired in 2020, there had been over time some libraries that hadn't been ported over to Python 3, but a significant number of libraries have been, and if they haven't, then there's a capacity to actually backport and support your project that may require Python 2.7. That's above and beyond the purview of this, but if anyone does have any questions, I will share my Twitter at the end of this, and you can feel free to reach out. So yes, Python 3, that is what you should be using. That is the Python of today, tomorrow, and everything going forward. So where is Python used? Well, places like Instagram, YouTube, Shopzilla, Google, they use Python in quite a bit. So I know that a bulk of their code is written in Python for YouTube, which is pretty nifty. But also Python's not just used in web development. It's used in many things like education. For example, in July 2014, 8 of the top 10 CS departments used Python for their intro computer science classes. Also, Python is embedded in the Raspberry Pi. The actual original image that you get, the Debian image, or Raspbian image, my bad, actually comes with Python installed on it. That's pretty awesome. And the microbit, which is a new initiative of the BBC in the UK, which is essentially like a Raspberry Pi, but smaller, more basic, kind of like an Arduino, where it's just going to be the motherboard. But this is an effort to get kids to code, so they're going to be using this in classrooms, and it comes with MicroPython, which is a smaller build of Python that allows it to actually do the thing. So outside of education, as I said before, we see it in web development, but we also do see Python in academics and science. Pretty cool. Python was in fact used to help detect the first gravitational waves. There's a link to the article there talking about how Python was used and what gravitational waves are. If you would like to actually know further details about that, you can check out the EuroPython. There was a keynote talking about how Python was used in detecting gravitational waves. So yeah, Python's used in academics and science, like astrophysics, astronomers. They use it. That's pretty cool. Data science being that space where we've got so much volume of data, and now we're having folks who, they may not be a subject area expert, so perhaps they're not an expert in like astrophysics, but these are folks who know how to apply, they know how to create models for machine learning. They have arguably, depends, I guess, on who you talk to, really good statistical modeling chops, but these are folks who also use Python. In civic tech, for example, I worked at Obama for America, and I used to use Python for data munging. So yay, civic tech. So yeah, Python has quite a lot of uses. Why does it have a lot of uses? Well, Python is an interpreted language. That means that Python does not require us to compile it, for example, like Java. Python's a dynamic language, meaning that we can on the fly create and not have to declare explicit types. We will be talking a little bit more about types. And oddly enough, though, Python is indeed strongly typed. So those three things together, interpreted, dynamic, strongly typed, essentially means that we can get to coding in Python quickly rather than having to do a lot of setup and boiler code, as you may see with languages like C or Java or lower level languages. Types in Python are indeed tracked. So when we do things with specific objects or specific types, we only have a certain set of actions, behavior, a certain set of actions, that is the behaviors that we can use on those objects, that for object type 1, object type 2, object type 3. So Python does indeed care about that. However, when we are creating variables, as we will be doing in a little bit, Python doesn't care what, it doesn't say, hey, you've actually created a variable of this type, and I'm only limiting you to have a variable for variable example. If you say example is one type, you are allowed to change that as you're coding. So if you're curious about that, again, click in. There is, this links into the documentation on the python.org website and has more information available for you. So I was rambling a little bit about some of this. Let's take a look at some code now. So the code snippet here, as we're reading the Python notebook, whenever you see some output beneath, essentially what that's doing is it's showing what the code you type produces. So when we have the code snippet and then an output beneath, that is just what that code produces. So if we were looking at this example and we were trying to think about, well, what does it mean that Python is strongly typed? Well, if I had a variable my name and I give it the value of Lorena, and I want to go print my name 3 times, so my name times 3, the output is going to be Lorena, Lorena, Lorena. It's going to just kind of glue those together. However, if I were to say, have another variable, my height, which has the value of a number of 66, and then I say, let's print the mathematical operation, my height divided by 12, we get 5.5. So when I do things like multiplication for objects that are including text versus objects that include numbers, those operations will be different. And just to drive that home a little bit more, let's take a look at what that kind of looks like. So this is the Python notebook we're working in. Well, let's try doing my height times 3. And when I do my height times 3, my output's going to be 198. So unlike a string, which is this text here, when I do multiplication, it's not going to have the idea of actually kind of gluing that thing together 3 times. It's instead going to do what we would think of as a mathematical operation. So back to that argument that Python is strongly typed. Well, yes, when we talk about objects and we talk about their behaviors, those behaviors are intrinsically going to be linked to the type of object. And also just to show that I can indeed have, that Python is indeed dynamic, that is that I can override a variable and give it a different object type. Let's just do this. My height equals 66. Let's cancel. I did that. And then I went to print my height times 3. And indeed, I get that 66 glued together 3 times. So pretty nifty. Okay. So if you want to install Python 3, as we saw, Python 2.7 does come installed on Mac machines. But since Python 2.7 is being retired in 2020 at that, I guess, very awesome party, we want to get Python 3. So to do that, you want to go ahead and head over to python.org. You can follow the download instructions. The latest and greatest is Python 3.5. Python 3.6 is scheduled to be released later this year. So if you don't have any particular requirements, I would say just go with the latest. You can get a beta version if you like, but why use beta if you're just starting to learn to play with Python? So you can click Python 3.5, and you can drill into it to see which version you want. They've got Windows, they've got Mac. Windows, you can easily find for whatever system you're using. You can easily Google and find YouTube videos to help you get that installation set up. For Windows, you'll have to do things like remember your Python path and just be cognizant if you're going to do a global installation or not. The other thing I did want to point out is if you would like to have 1+ versions of Python on your machine, you can definitely do that. So on my machine, for example, I've got both versions of Python set up, so you can create an alias. So as I showed before, when I type Python, I get Python 2.7. If I want to do Python 3, it indeed allows me to do that. So what you would have to do is create an alias in your bash profile. And if you would like to do that, there is some discussion. There is a link to a YouTube video here on how to do that. You can also use a virtual environment, which is pretty much a little cool tool that allows you to create small controlled environments for each of your Python projects. If you would like to do that and know more how to create them, go ahead and create the environments following these instructions. And actually, if you go to the repository for this chat today, Python crash course, you'll notice that there is this requirements.txt. Whenever you create a Python environment, you can itemize specific dependencies that you would like to use when you set up an environment. If you do that, you can say, so this is actually the actual Python environment I have here is named env. You know your environment's activated when you see the parentheses in your terminal and the name of your environment. So I could do with a virtual environment, I could say, I could create my virtual environment and then pip, which is the Python package manager. I could say pip install from my requirements file, all of those dependencies, and they're listed. Again, if this is kind of quick, you can follow along with that link in the slides, which is right here. However, if you would like to just play with Python 3 online, you definitely can. There's repl.it, which is pretty nifty. So Python 3, you can go ahead and start doing some of the things that we were doing earlier and get to work right away. There's also CodePen and Cloud9. Cloud9 is pretty cool because it allows you to have kind of like a virtual environment, like a broader virtual environment where if you have like a repository from your GitHub account that you would like to go ahead and clone, you can go ahead and do that. And then if you actually launch your code in here, it gives you kind of like an IDE, an interactive developer environment. So you can have your code in the top, and then you can have a bash shell at the bottom. So that's pretty awesome if you would like to go ahead and play with Python on your own and maybe not have to install it. So let's go ahead and get to talking about what does Python syntax look like. So I think I said that the Python documentation can be a little, depending on how new you are to coding, it can feel not as user-friendly. And this is a really good example, I think. This is a description of the BNF, the Backus Naur form notation, which essentially is a way that you can describe a grammar-free syntax for a programming language. So this describes some of the rules of Python. And if I were to read it, and I'm just going to read the first bit, I think you'll get some insight about how the documentation can feel a little deep. So the example here says, the first line says that a name is a letter C, is an LC underscore letter followed by a sequence of 0 or more LC underscore letters and underscores. A LC underscore letter is in turn is any of a single characters A through Z. So yeah, that doesn't really tell me much. It is attempting to describe what the syntax looks like and how Python rules work. If you are, I think this may be more accessible to you, and perhaps if you would like to read more about that, you can go ahead and click in here. It's on the Python Introduction 1.2 notation. You can find that, but I instead encourage you to just go ahead and follow along with me instead. So Python types. Okay, so we've already saw some examples of Python types, but what exactly does that mean? Okay, well in Python, everything's an object. And while we can use Python as a glorified calculator, we probably want to do other things. So first things first, in Python, everything's an object. What's an object? An object tells us what type of a thing is. So for example, with these 4 variables, my int equals 1, 2, 3, my float equals 1.0, my stir equals my stir, my bool equals false. So 4 variables with 4 different object types. If I am curious what these object types are, we have a built-in function called type that we can use, and you would provide an object to type, and then that will give you that will then indeed tell you what kind of object that thing is. So the idea of what we think of as a number, a whole number is an int. What we think of with fractions or floating points, hence float, is going to be 1.0. Or 25.2 or 29.333. So anything with a actual decimal point, anything with text, and you can define strings with double quotes or single quotes, but you cannot mix them. You cannot mix the two. So I couldn't say, for example, let's go ahead and get this started. I could not say, hello class, like that. Python does not understand what that is. You have to use the double quotes or single quotes, one or the other. And then my bool, that's the idea of truthy false. If you want to represent something as true or false, it is going to be capitalized, and we call those booleans. So that's nothing new. So yes, Python has types just like other programming languages that we've seen before. And what about collections? So Python has lists and it has dictionaries. And yes, these lists and dictionaries can contain multiple object types. So in the example here with my list, it has a float, it has a string, and it has numbers in it. Exciting. Dictionaries are precisely like what you think. Or if you haven't heard that word before or aren't familiar with this kind of data structure, you can think of it as the actual English dictionary. You get a word, and then it gives you definition. Or in this example here, you could think of it like a translation. So if I say hi in English, in Spanish, it's hola. If I say bye in English, in Spanish, it's adios. So we've got collections. If we want to hold more than one thing, we can do the key value pair, which is the dictionary, or we can do it where we have an ordered collection, which is a list. So with Python, we also want to be able to combine all of our objects together to do more dynamic, fun things. So with Python, we can, of course, chain together our objects to make more dynamic logic. So we've got our traditional if statements. So if you all is having fun, and the idea here of you all and having fun would be 2 variables. So if this condition is true, print yay, else print boo. Oops, looks like there is a parenthesis left off. That would be invalid code. So when you use the print, you have to use a opening parenthesis, provide the thing you want to print, and then a closing parenthesis. But to speak this back, if this condition is true, print yay, else print boo. So pretty straightforward, nothing too unique in terms of programming. I do want to call out that yes, you can write if statements in one line, should you like, but that's generally seen as not very Pythonic. So if we were to rewrite that into a one-liner, we would say, if this condition is true, true would be on the left-hand side of the condition, else boo. So else would be the false. So if you're having fun, print yay, or assign yay to message, else assign boot to message. We've got basic looping as well. So if we were going to loop over a list using a for loop, we would say for whatever variable name you'd like. Variable names in Python, we do like to use lowercase characters. And if you are going to have the idea of more than one word, we use underscores. So snake case, very appropriate because it is Python. So snake case, not camel case. So for variables in collection, do something with it. So in this case, we're going to print it. We also get the idea of a while loop. So while this condition is true, go ahead and do stuff. So we can use a counter to say, hey, while the count is less than the length of the list that I'm iterating over, go ahead and print the element. So we've got for loops, we've got while loops. If we were going to do a for loop with a dictionary, we would just have two variables, one to represent the key and one to represent the associated value to the key. So it'd be for key, comma, value in my dictionary, print key, comma, value, for example. Or just to show you what that would look like, we could say my dict equals for key value in my dict, print key value. Pretty exciting. Alrighty, so list comprehensions, what are those? This is an example of something that we like to say is Pythonic, and I don't expect you to quite know what Pythonic means at this point in time, but if we wanted to do something like remove items out of a list, we could do a for loop and say for item in my list, if item doesn't meet whatever conditions I want, delete it from my list. I could do that. Instead, what we say is Pythonic to reduce a list is just do this list comprehension. So the idea here is if we have a bag of words and we've got all of these words and we wanted to remove any word that doesn't begin with an H, we would do almost like a one-line for loop with an inline if statement, but we contain that within the left square bracket and right square bracket. So for word and bag of words, if H in word, so again, following that one-line convention, if condition is true, put the true condition on the left-hand side. If you did want to chain an else, it'd be kind of like what we saw before, else and then condition on the right-hand side. So the oddity here, we would say it is Pythonic to do an inline if statement when you do a list comprehension, but it was not per se Pythonic to do a one-line statement like that. So kind of interesting, but list comprehensions are pretty cool. And in Python, just to kind of reiterate that there's many ways to do a thing, there is indeed this idea of using lambdas, which are anonymous functions, something that comes from functional programming. And also we have this idea of filters. So let's read this one out loud. We say bag of words equals, and let's start with the inside. So lambda is going to be an anonymous function. It is not something named. We're kind of creating the definition on the fly. We say word. So word is going to be the variable to represent every item in the collection. We say if H in word, so that condition has to be true. If H is in word, we're going to go ahead and keep it. If the H is not in the word, we're going to filter it out. So the way that lambda kind of works is we're providing the truth condition, the thing that we want to filter out of, and we call filter. So filter says first argument, give me the definition of what you want to keep in and what you don't want to keep in. And then the second is going to be the actual thing you want to filter on. And in Python 3, when you call filter, it does give you back not a list, but a generator. So you're gonna, if you want to actually coerce that generator to be a list, you can call explicitly list on that. So kind of like what we saw before, when you create a list, we can do it with the square brackets. We also have an accompanying built-in method, which is just called list, and you can do the same thing. Oh my goodness. Here, let's do this one. Code samples on the fly is always exciting. Oh goodness. Okay, so let's go ahead and talk about Python functions. So if a lambda is an anonymous function where you're kind of creating the definition on the fly, the Python functions, if you want to create something that's reusable, or rather maybe more transparent, easier to kind of understand what your functions are, not an anonymous function, that is something named, we can use the def keyword. So def say hello, keyword def is going to start the function. The syntax then says name the function again. If we use anything that's more than one word, use an underscore, and we can have 1+ arguments or actually no arguments. So if you have 1+ arguments, they're going to be comma separated between the parentheses. And in this example here, we're going to say this function is going to accept information like a name, and we're going to return a string that says hello plus name. So in Python functions, we need to do an explicit return. There, if you do not use the return keyword, you're just going to get none to come back. So make sure you do use a return keyword if you actually want to return a thing. Okay, so let's go ahead and try this one out. Okay, so example list. And for number in example list, print number. Uh-oh, indentation error. What is that talking about? Okay, I couldn't help myself. I'm a big Jurassic Park fan. This is kind of what I think every time I forget that white space matters in Python. And there is a lot of debate between tab or 4 spaces. I would say whatever you do it consistently. You can actually read more about that with the PEP. PEP is kind of like the best, is like best practices. It's the collective communal definition of what Python, of how Python should be done, how things ought to work. So PEP 8, tab versus spaces, you can definitely go all the way through and see what folks say. So I encourage you to check that out. PEP 8, a style guide. Tab, let's see what they say. Tab or spaces. Tab should be used solely to remain consistent with code that is already indented with tabs. So the first line there says spaces are the preferred indentation, but you'll notice there's a caveat that says tabs can also be used if tabs are already used. So really, whichever one you use, be consistent. You will get some quirky things in your code if you mix the two, or if you copy paste code and you paste code into a new file, and maybe the code was originally written with tabs and then you start using spaces. You'll see Python doesn't like that and it gets cranky. So if you ever say anything like indentation error, it means your white space count is off. So long story short, use a tab or use 4 spaces. So if we were just to do this one again for number and example list, 1, 2, 3, 4, print number, boom, it works. You don't want to be like Jurassic Park and get locked out. All right, cool. So let us continue. Oh, whoops, that's right. Here we go. Okay, so white space, it really does matter. Okay, so I've been saying things like this is Pythonic or this isn't Pythonic. One way I could kind of tell you, one way I already showed you is like how you can kind of go ahead and look around to get a definition of what folks who do Python code do and what they believe is best practices. You can go ahead and look up the PEP 8, which as you notice, is on python.org. This guy right here, PEP8. I will also actually add this into the slides after the fact. But yeah, you can check out PEP8. There's lots of heated discussions about things like maximum line length. You can also get some Python modules that actually do PEP8 checks on your code and will automatically fix it. I did not profile that in this chat, but it's something that's pretty nifty. I encourage you to go check it out. But also there's this fun thing by Tim Peters. It's called the Zen of Python. So if you've ever read any beginner introduction to Python, I'm quite positive you've come across the Zen of Python. It's a little tongue in cheek, but I think it does capture a lot of that sentiment all the way back to the beginning about when Guido talked about his philosophy for Python. This idea here that Python is an experiment in how much freedom programmers need. Too much freedom and nobody can read one another's code. Too little and expressiveness is endangered. So really, Python is meant to be human readable. That was an early on decision by Guido. He believed that humans write code, so it should be enjoyable to read, easy to read. We should always err on the side of having clear, expressive code and not code that is just kind of difficult to read. So kind of that example of doing a one-line if statement. The one-line if statement, yes, you can write your code that way, but it subtracts, arguably, it can subtract from the expressiveness of your code. So why not just write it as, why not write that if else statement across 4 lines of code rather than 1? I think, these of course aren't mandates, but you'll find that people, when the style of what it means to write Python code is kind of discussed, there's always that big question of, hey, is this human readable? Are we jamming too much in there that is just making it convoluted and complicated? If instead, maybe instead of doing 1 line, we write in 4 lines. Instead of having arbitrary, difficult to parse logic, can we perhaps add a few more lines of code, which, yeah, maybe it adds a few more lines of code, but it makes it more human readable. We tend to want to write code that errs on the side of being more human readable. So some of the Zen of Python here, beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Readability counts. So yeah, you can actually go and check this out and get kind of a feel. And there's been quite a few folk who've written their opinions on what it means to write good Python code. But really, the end of the day is write code that if you had to go debug your code at 2 in the morning, we want to write code that you wouldn't mind debugging at 2 in the morning. We want to write code that is meant for other humans to read and less about optimizing optimizing for the machine. So let's go ahead and get to it then. So Python modules. So Python comes with a built-in REPL. REPL meaning read, eval, print, loop. If you want to know all of the modules that comes with Python, you can just a little nifty command, this help modules. So let's go ahead and check that out real quick. So it says, please wait a moment while I gather a list of all the available modules. And essentially what this does is it tells me all of the libraries, modules meaning libraries, that I have installed that I can use. So if I forgot for some reason that I don't know, maybe I forgot that I had something installed, or I want to double check that I have something installed. So today I'm using Jupyter, which is what this cool interactive thing is, where I can create slides and write code and evaluate it inline and also have slides. There we go. So I see that Jupyter is installed, and let's take a look at some other ones. So when it comes to Python modules, Jupyter is really awesome. I really enjoy it. SciPy, so scikit-learn, your scientific computing stuff, that's going to be SciPy. Seaborn is something you can use for expanded colors. If you're using Python for mathematical computations and you want to have better PyLab is something we can use to make charts, but it doesn't have a very awesome set of colors and font. I know it comes with an extended color palette, and it comes with expanded ways you can draw lines and thicknesses and things like that. You can use Seaborn, which is pretty cool. Asyncio, this is pretty neat. This is from Python 3.4 forward, which allows you to do concurrent programming in Python. You've got event loops. It's pretty neat. Facebook is rocking it with this. There's a great PyCon 2016 talk from one of the Python core developers talking about async IO. I encourage you to check that out. Requests. This is by far probably my #1 most used Python module. Requests is HTTP for humans. Kenneth Reitz of Heroku and a Python Software Foundation fellow. He wrote a bunch of great things like the Hitchhiker's Guide to Python, which we'll chat about at the end here. But he wrote these really beautiful APIs that they have great simple user interface and make things easy. And a lot of his modules, like he wrote another one called Records, databases for humans. It's kind of following that idea of being explicit and writing human readable code to the extreme. But yeah, he writes really great modules. So requests allows you to do what you would think, make HTTP requests. We'll actually be using that in the code snippet we're gonna run through. Let's see, what else here is pretty cool that I use often. Oh, so you'll see like this PyTZ, and not that. So PyLab, that's what I meant. PyLab is what I was talking about for drawing charts. HMAC, if you need a hash, do security stuff, that is neat. You'll see this grab tweets. That's actually the name of my Python script we're gonna run. Some modules, it will also pull in your stuff as well. And func tools, like filter, map. There is some functional programming stuff in Python. I actually have a separate chat on my YouTube channel if you want to check that out. Not that functional programming is on a 1-to-1 ratio with Python, but there is these higher order functions you can use. You can check them out in func tools, and it kind of gets closer to that functional programming paradigm. Let's see. Time, pretty much what you would think to do time profiling. And pandas, more stuff for doing like working with data frames, working with large data sets, pretty neat. And is there anything else I want to chat about? Yeah, I think that's it. Actually, there's another one called Beautiful Soup. BD4. Beautiful Soup is for parsing HTML and XML. It's really awesome. So I use probably Beautiful Soup quite a lot. I use Request quite a lot. And as I am playing around and doing more stuff with data munging, data cleaning, I'll use Pandas, NumPy, Seaborn, things like that. And if you're into machine learning, scikit-learn is super cool. It does a lot of fun things. But yeah, let's continue on. So if you want to know the name of your modules, you can do that nifty built-in command, help in quotes modules. If you would like to see the functions within a module, you can do help, then the name of the module. If you haven't imported the Python module, you would need to use that within quotes. And let's go ahead and talk about what import is. So let's say I want to know all the reserved keywords in Python. There's a module for that. So actually, we can see that here. I know I saw it. There we go. So this keyword thing, let's go ahead and try this out. Import keyword. All keywords equals keyword.kw list. So let's go ahead and look at this. This dir, it actually provides reflection on the Python object in question, and it'll give you the name of properties and methods available to this thing. So I see that I've got this count, extend. So it looks like it's a list of some sort. Let's try and do a type on this. See what it tells me. It is indeed a list. That's pretty cool. Call it, and let's actually look at that. So here's a list of all reserved keywords in Python. These are words that do an explicit thing and that you really shouldn't go and try to write over, because that will make Python act weird. So we saw the Booleans, this true, false, none meaning none. So again, capitalized. We saw some of that with some of the logical operators. We saw the if you all is having fun. That is access allows us to do some logic operations. The while for the while loop. With we can say with open a file. When you use the reserved keyword with, it allows you to do things like if you're opening a file, once you are done working with the file, once depending on what you're doing, you might want to close that file. If you use the with keyword when you open a file, it actually will call that. It will actually close that file by default. If you're curious about that, go check it out. Let's see. Finally, you can do when you do exception handling, you can say try right here. Try to do a thing, except if you catch a condition. If you do catch a condition, if you want to have a final operation you do, like maybe finally stop the program. So these three would be used together. But yeah, you see this import. So import allows you to bring in modules, Python modules. So if you're curious about other things you can do, so like we were saying, help keyword. If you use this nifty help feature, it's going to give you the expanded documentation on the module in question. So much like when you are using any help command from the terminal, you are going to want to go ahead and use Vim keyboard ideas, so Q to quit, but you can see that it gives you a definition of functions, what kind of data is in it, et cetera, et cetera. It's pretty cool. So if you're in there and you're playing around with Python modules, help is going to be a fun one to use, and you can use that dir to check out what functions are available in it as well. So cool. Okay, so Python modules, we've seen how we can use them. We've played a little bit in using the REPL. What else can we do with Python? Well, let's go ahead and get to demo time. So I am actually going to pause and see if there is anyone who has a question. Don't think I've turned on, oh, actually I did not turn on questions. So this is what I will do. If anyone does have questions for me after the fact, I am more than happy to chat. I will make sure to tweet at the end of this or share my Twitter handle. I think I did not put my Twitter handle on the slides. But that being said, we can always update that, and I will make sure to put my Twitter handle in here. So if you all have questions for me, you can reach me. There we go. I have a very long, fun Twitter handle. Okay, so demo time. Let's go ahead and take a look at some code. Okay, so I use PyCharm, JetBrains. This is for your IDE, interactive developer environment. It's pretty cool. I'll just spend a second kind of running through this. So you can when you have a Python script, if you do a double click, you can go ahead and say run. You can run your thing. You can do a debugger. But for folks who debug if you do JavaScript, I think pretty much any IDE has the same thing. You click on the left-hand side, it's going to put a red line. That'll put a breakpoint. You can have multiple breakpoints. It's pretty nifty. And for folks who want to use virtual environments, you can indeed do that. So with Python interpreter, if you actually have a virtual environment you want to use, you can select from there. As you can see here, I've got like a bunch of like pre-installed ones. You can also set that by going to the project settings. So preferences and project interpreter, and then you can actually go ahead and add a local and find where that Python environment is on your computer. But anyways, let's chat a little bit. So you'll notice in the code on GitHub that this nifty little thing called grab tweets, there's a lot of extra kind of stuff, a lot of extra bells and whistles in here. But I do want to call out this stuff right here. This fill me in. So whenever you're working with getting data from someone else, so we call that API. If you want to get data from an API, that is data that someone else owns, but they make publicly accessible through their API, you're going to need, more likely than not, credentials. Basically saying, I'm going to go ahead and play nicely and not do malicious things like attack your system. I'm going to agree to the contract that you provide of how I can access and use to get your data and here's my credentials to say that I'm playing along nicely. For Twitter, you should make sure to not actually commit these. You can actually work with a YAML file that is a key value flat file with the extension .yml or whatever file type you'd like, and have your credentials in there, and make sure you don't commit them. But with Twitter, you can just go to apps.twitter.com, and you can create an application. It's pretty straightforward. So if I go to apps.twitter.com, you can go ahead and create a new app, and then from there, decide what you want to do. So I've got a whole bunch of fun things in here. So when I want to get data from Twitter, I get credentials given to me automatically. So the 4 things I would need to grab: I need consumer key, I need a consumer secret, and then I need, so these keys identify my Twitter application. And then I, as a user for my Twitter application, need additional credentials, this access token and this access token secret. So if you want to play along, or you want to do this on your own, if you fork the code, just know that you'll have to go to apps.twitter.com, register an application, get the credentials, and then plug them into this file at that top here. So you'll see I've already done this, pretty nifty. So let's go ahead and read some of this code. We're just gonna actually focus on some of the more basic stuff here, but we're going to, as I said, use that request library. I love this guy. This is gonna allow me to get to do a GET request and get data from the Twitter API. In order to authenticate myself, I'm going to use the OAuth1 authentication. And the base64 we're actually not going to be playing with for today, and the codex we're not going to be playing with for today. So I'm just actually going to comment that out. For Python, when we do comments, it is a octothorpe. You can also do multi-string, multi-line strings. It'll be 3. Again, single or double quote, do not mix. It'll be 3 and 3, and then you can go ahead and write your thing. That below. So yeah, so we're going to be using requests to go ahead and get data. We're going to use OAuth1 to go ahead and get authenticated. We've got our credentials. We have the URL for the Twitter API here. If you need more information about that, go check out the Twitter API docs. Pretty awesome and straightforward. And we've got a bunch of functions. So let's actually go to the bottom of this file. So if you're reading over any Python code and you see this if name is equal to main, essentially what that's saying is if this is the main file, then I want you to go ahead and execute this code below. So that's pretty much what this is doing. So the code that's actually going to execute, I've got this thing that says, hey, I'm going to make a function. I'm calling the function or the method get Twitter client. And it looks like I'm going to be providing those OAuth tokens that I defined above, and I get a Twitter client. From the Twitter client, I'm going to get a timeline. So the timeline is your home timeline, meaning here, home timeline is this guy here. It's like all the tweets on my home page. So I'm going to go ahead, get my home timeline, and I'm going to just say for tweet in timeline. So this is a for loop, so we can assume that I'm working with some kind of collection. I don't have 2 variables defined, so we can presume I'm working with a list. So for each tweet in my timeline list, I'm going to do some stuff. This /n is a new line character. I'm going to print a new line. From the tweet, I'm going to get the user and the screen name. So I'm going to pop that into a variable screen name, and then I'm going to go ahead and say, hey, this screen name says this tweet. It's pretty exciting, I know. I don't really actually care about that line, and cool. So for each tweet in my timeline, I'm going to print the string with the screen name, what they say, and the text. Pretty cool. So let's go ahead and take this first thing. So I'm going to actually run this down here in my IDE. I can actually zoom in, which is pretty nifty. I love that because I do wear glasses. So let's check this out. Okay, cool. So I ran this script, and let's actually see what happened. So it looks like PyBay. Oh, there's actually, I think it was last weekend, a Python conference called PyBay in San Diego or San Francisco. So it looks like they are tweeting some stuff. Anything fun in here? I don't know. Let's see. Looks like some folks are coding it as well in New York. Exciting. Blue 1647 for those folks in Chicago. This is a really cool incubator space in the largely Latino neighborhood, Pilsen. Looks like they're doing some stuff. They're retweeting some stuff. Exciting. Well, anyways, it looks like I was successful. I was able to print the screen name. I interpolated this text says, and then I grabbed the text of the tweet. And I also added as a kind of like a delimiter. I have a new line, and then I did this thing just to kind of clear up and make it more human readable. All right, cool. So that's Python code for doing stuff. Let's drill into it a little bit more. So what is this get Twitter client doing? Well, all it's doing, and remember when I said we can have multi-line comments, I would say it is really awesome practice to have, this might be a little hard to read, so I'll kind of keep it highlighted. I love when people write me some doc strings and they tell me what this function is doing. So be a good human, be a good human who loves Python and add them to your code. So essentially here, all this is saying is this accepts 2 parameters, OAuth secret, and that should be OAuth token, my bad. Finding mistakes on the fly. Oh, I guess that would be OAuth secret and OAuth token. Okay, cool. This doesn't do anything super exciting. It's just using that OAuth 1 that I imported at the top of the file, and it gives me the authentication that I need to get the Twitter client. So I provide it all the credentials, and I return it from this function. Okay, cool. So that's the first function. What about the second one? Get timeline. Cool. So let's zoom this one out a little bit so we can read it a little bit better. And get timeline. This is going to accept that Twitter client, which is that thing we know that we've created above with this OAuth 1 thing. And let's see what this doc string tells me. It says it's going to retrieve an authenticated Twitter user's home timeline. And what it needs is a Twitter client, and what it will return is addictive Twitter user's home timeline. Neato. So what exactly does that mean? It means I'm going to go ahead and with requests, I'm going to make an HTTP request and say, hey, from the home timeline, I want to access, or from the Twitter API, I want to access the authenticated user's home timeline. The authentication I'm going to provide is the Twitter client. And when I return it, again, the request is so great. You can just easily say, I want to get the JSON of the response JSON object, and you can just call it .json. If you are curious more about requests and how to work with it, again, you can use that help module, or you can check out HTTP for Humans. It's got great documentation. But yeah, it really is that easy. You just make an HTTP GET request, you provide the Twitter authentication, and then you just get the JSON of the response. And that then gives us the timeline. So let's actually put a breakpoint in here just because I like seeing things and it makes my life easier. Okay, cool. So now I've currently stopped, and I'm going to look at some of the data that's come back. So timeline. So as we saw, we've got this list of what looks like dictionaries, and these dictionaries, I think, are tweets. So if I was going to check out tweet, this might be a little, not sure if I can make this much bigger, my apologies. But if you want to check this out on your own, you can check out PyCharm and use breakpoint. But essentially, this variable tweet is indeed a dictionary. We know it's a dictionary because it's got the curly brackets and it has key value pairs. So this is a multi-dimensional dictionary. The topmost key is retweeted status, and then the value is a bunch of information about things. So you'll see that there's this tweet.getUser. So when we grab something out of a dictionary, we can use get to do a safe lookup. So if that key doesn't exist, it's going to return none to me rather than give me an exception that says, hey, I don't have this key. Granted, if you were to think this through, if I had tweet.getUser and that evaluated to none, and then I said none.get, so I'm asking the none object to get a key to get a dictionary key screen name, that's actually going to cause an error. So this is not exactly the most offensive code, but get is a nice, safe way to check if a key exists. Otherwise, you get a fallback, which you can define one, or by default, it goes to none. So for tweet.getUser, let's go see if I can find that. Okay, cool. Here's a user. And user looks like it's got information about how many things it's been favorited, the screen name, profile, image, and some other stuff. So from there, I want to get the screen name. And oh my gosh, there's a lot of stuff in here. But yeah, so cool. So that's what that's doing. And likewise, from the tweet, you can get the text, and you can also drill in to get more information. But yeah, so with Python, I think what we can see right away is with Python, it's pretty, this reads like English, right? It's, you know, for tweet and timeline, for each tweet in the user's timeline, I want to go ahead and get the screen name, and then I want to print the screen name and the text of the tweet. So that's little guy in action. If you would like to play more with this, I'm not going to actually go into it today since we're just about at time. But this is kind of fun. So I've got some stuff that I didn't use today, but this NLTK is the natural language toolkit. And for anyone who's done any kind of, or rather has heard of anything like sentiment analysis or natural language processing, NLTK has a bunch of built-in stuff to let you do that. So for example, what you could do is when you do natural language processing, for example, maybe you want to analyze if a text, like an Amazon review, is positive or negative, and you look at the words to try to understand, to derive some meaning. When you look at that review, you might want to filter out, remove words that are very common in the English language, like the, or, but. So those are called stop words. So actually, the natural language toolkit has all the stop words for. I'm not sure how many languages it has, but I know it definitely has for English and other languages. So you know what could be kind of cool is maybe you do a little project where you collect tweets for a while, and then you get all the words. And so what you'll notice that this kind of text has, or rather what this boiler code has set up, is it says, I'm going to go ahead and collect words, and we're going to make a dictionary of word counts. So essentially, remember how I said this get does a safe lookup? It says if words.get, the default, you can provide, the backup default here is 0. So if there's a word in my dictionary, go ahead and increment that word's count by 1. Otherwise, record it as being the first time we've seen it. So if you do that, you know, maybe up here you create some stuff that says filter out, or rather that wouldn't be there. That would be here, right? You would have to say, you know, filter out stop words, and then maybe you can collect some words and do a histogram of words seen. Maybe you can actually query Twitter and say, I want to look up a hashtag. So right now, what's trending? We've got weird conversation starters. I don't know. Maybe that's something you want to look up. But maybe you want to do some language analysis around what this hashtag, what people are saying, and I don't know. Maybe you want to see if like this is a comedic or has some humor. If this hashtag has some humor, I don't know. If you go to town, so you've got some stuff set up. There's some other random things in here that I did not go into, but it includes an API for getting cow ASCII art. It's kind of silly. And I think that's really the rest of what's in here. But if you want to play with it, I encourage you to. So I remember I was talking about PyLab. So if you wanted to do some graphing, you could use PyLab. So some of that is commented out. PP is pretty print, so it gives you a better print format if you would like to use that. I'm actually not using it in this code snippet, but anyways, the end of the game is when you want to do some Python stuff, import your stuff at the top. If you have variables, so with Python, anything capitalized, we consider a constant. These aren't true constants, it's by convention only, but you know, this communicates that there's something strong about it, so we've got some constants here. Arguably, these could be constants. I didn't really do that. Arguably, this should be too, but I digress. So yeah, you can define some constants, define some functions, and then if you want to make this a Python executable, we could actually make Python executable by doing Octothorpe user bin Python. And you can then also say this line 69, that says, hey, if this is the only Python file I have, run this code. Cool. Anyways, that's all on the GitHub repo. And let's go ahead and just end with some good resources. Okie dokie. Okay, so want to continue learning? Let's check out some of this stuff. Oops, looks like I didn't put these links in, but I will actually update that at the end here. So some really awesome things that I love. So I've made reference to all the cool things that Kenneth Reitz has worked on. So Hitchhiker Guide to Python, I love this. There is a free one that is online. This is really nifty. It gives you a lot of explanation about best practices, goes into depth about further things we didn't chat about, like Python decorators, higher order functions. What's that mean in Python? Goes into Python classes. And as we talked about, some Pepe, Zen of Python, or just like general conventions. So yeah, this is a really cool thing to check out. And a colleague of mine actually did an extended book adaptation of this with Kenneth Reitz. She is here in Chicago. She's an awesome person. But yeah, if you want to read an extended version, you can check this one out. Or you can check out the condensed version, which is docs.python-guide.org and the Hitchhiker's Guide to Python. Another one I really like is Learn Python the Hard Way. They actually have a few. I know they have it for Ruby as well. I'm not sure how many other languages, but this just gives you a bunch of different exercises you can check out. So yeah, if you want to have more interactive kind of things rather maybe than passive, this is a cool thing to do. And of course, I always encourage people to check out their local Python user group. So in Chicago, we have PyLadies, but you can also go to PyLadies.com and check out the chapters. So they've got a locations, which is pretty nifty. And of course, you can go to python.org and look for user groups. So yes, if you were to query Python user groups, you've got listings there as well. There's a lot of mailing lists you can check out. But yeah, there's a lot of ways to continue with your learning. So please do tweet me if you have any questions. I will make these, I will actually add these as links. And my Twitter handle is LOOOO. That is 4 O's. Kind of think goal, like in football, goal. So Lorena Nicole. So you can tweet me if you have any questions. This notebook is on the GitHub repository. The GitHub repository is also linked on the Python class, so you can check it out. And for those of you who like Jupyter, I was actually having way too much fun trying to customize the CSS. You get a different default. I actually discovered you can override it by creating custom CSS. So cool, that's that. And there is a bunch of themes that this gentleman created. I will update more of the README though with some of the other links. And that will do it. So I do appreciate you for hanging out with me today. And like I said, this is definitely a crash course, not a full definition of everything, but I'm more than happy to chat with anyone who has questions after the fact. Otherwise, go on, live long, and Python code. Thank you.